Hello, I'm Kevin Sala from Lawrence Livermore. I will talk about LLVM Advisor, which is a unified visualization tool for compiler artifacts. This is actually a GSOC project developed by Miguel Cárdenas, and I'm one of the mentors. So basically, you already know that LLVM reports a high amount of available compilation data. We can get optimization remarks, profiling, timing, and also diagnostics. But the problem comes when we have multiple of the compilation flags to enable all this data to be reported. And the output files that we get are different. The output data formats are also different, and it becomes quite difficult to find, for instance, remarks in a specific region of our code. For instance, when we are trying to tune the performance on some specific regions. So here it comes one of the solutions. This is the LLVM Advisor. It's basically a unified infrastructure. It's a tool that first gathers information about the compilation of your application using a compiler wrapper called LLVM Advisor. And then it organizes this compilation data, it stores them in a folder, and then it analyzes the data, correlates it, and finally you can be able to visualize all that data in a modern web interface. So how that works? Basically, you have your compilation command or linking command with Clang. You have to put the LLVM Advisor command just in front of your compilation command, and then it will gather all the information that we get during the command compilation. And then it just creates internally a folder with all that information, for instance, the LLVM IR, the assembly, the AST3, the diagnostics for each of your translation units. And then finally, you can see all this data organized in a modern way in a web interface that is also called LLVM Advisor. On one side, we see the main tab. This is the dashboard. We show some general information about the compilation of your application. For instance, the total number of files that you have, the distribution of remarks, the diagnostics, how many diagnostics of each type, the compilation time that you got, binary size breakdown, and also a summary of the optimization passes and optimization remarks that have been reported. Then there is another tab, which is the performance one. In this case, we show for now two different traces of the compilation time trace, where we show how much time is spent in each of the passes. And then there is, for the case of your application that offloads to the GPU, you can see the runtime trace of the offloading part, and it shows how much time is spent on each of the operations on the GPU. Then there is a third tab where we call the Explorer tab. In this case, you can display the source code of your application in C, C++, Fortran. Then you can enable the diagnostics or remarks in those small tabs. And they are shown just on top of the line that they were reported, so you can check them. And in the other side, you can display the different generated outputs for that source file. For instance, you can show the LLVM IR, you can show the assembly code. So who can benefit from the LLVM Advisor? We think that the advanced developers in LLVM, they could use them for reducing the time of having to go through the file of optimization remarks and finding the specific part where they are interested. Newcomers in LLVM would be also could benefit from it to be easier to introduce themselves into the LLVM infrastructure and the compilation. And finally, educators and professors in university, so they can be used for their students. So if you have any question, visit the poster session tomorrow. I will be there with a poster. As I said, this is a work performed by Miguel Cárdenas, a student from the University of Medellin. You can contact him too. And finally, I have left here a QR for trying, if you want, the LLVM Advisor live preview and the PR, which is under review. So any comment or feedback is very welcome. Thank you very much.